Hello, I'm Brendan, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. Today, we are going to continue with our second installment of the carboxylic acid series. Previously, we learned how to synthesize and break down carboxylic acids. Now we want to know what to react them with. This video will cover the basic and most common reactions you need to know. This is by far the most important topic on organic chemistry that you'll see on the MCAT. Before digging into the various reactions, let's examine the structure of a carboxylic acid. The two oxygens do a really great job of being electron withdrawing groups. This makes the oxygens partially negative. And if these are partially negative because they're withdrawing the electrons, we want to know, well, where are they withdrawing them from? From that carbon in the middle. That's going to make that carbon electron poor and have a partially positive charge. And whenever we see these partial positive charges, we know it's unstable. This is organic chemistry language for instability and therefore likely to react. So what type of thing is going to react with a partially positive carbon? Something that loves positive charges. The vocab for this is a nucleophile. Literally, positive loving. Let's explore the general reaction any nucleophile will have with a carboxylic acid. We'll begin with that nucleophile attacking the partial positive charge that we pointed out earlier. When it attacks this partially positive charge, this is going to cause one of the electron pairs to pop up onto the oxygen. This is going to produce an intermediate, super unstable compound called an alkoxide ion intermediate. So I'll draw out those electrons so we can very explicitly see what's going on here. From here, we need to become more stable. We know that this can't last long. One of those electron groups we brought up to the oxygen is going to come slamming back down. And when it does that, it's going to kick off whatever that Y group was. This is going to result in a change from that original Y group to now having that nucleophile. I'm going to highlight this with color here. Let's say that Y was green to begin with. Well, by the time we finished with it with that nucleophile, let's say the nucleophile is blue, the nucleophile has replaced it. So this is a very, very powerful reaction that we call a nucleophilic acyl substitution. This exact same mechanism can be used to produce an acid halide. Again, let's start with a generic carboxylic acid. Now we're going to react it with SOCl2. We could do this with any halogen, so replace the chlorine with anything you want. Bromine, fluorine, I guess it's fluoride, bromide. Either of those will work just as well. And it's a simple replacement. So I'll skip that intermediate step and just show you we're going to stick on a chlorine. This is our acid halide synthesis. The third reaction we want to look at is to see how to make a really important functional group in organic chemistry called an amide. And a really great example of when we're doing amide syntheses are with making amino acids. So let's see what that looks like. We know that an amino acid has a carboxylic acid group and an amino group. Let's combine those. Say we've got something like this for our starting groups. Well, if we react it with something called DCC, these will join together, where we'll have this nitrogen come up again, attack this, pop that up. We'll have an unstable intermediate. We've got that nitrogen hanging off, connected to something like this. Our unstable ion is going to take those electrons, come down, pop off the alcohol. And it's going to leave us something like this. We've essentially replaced the alcohol group on that carboxylic acid with the amino, this NR group. Essentially, what we've made is a dipeptide. And we know that the MCAT loves testing your amino acid knowledge. And this is a great way for them to fit in some organic chemistry on the bio or biochemistry section. So you want to be sure you feel comfortable with the amide synthesis. But don't let this be too scary. Again, the same general reaction is the exact same as the nucleophilic acyl substitution. Let's say that this OH is in green here. We're just replacing that entire OH with this whole nucleophile. Believe us, the nucleophile replacing it. And I didn't bother showing that the alcohol gets taken care of, turned into water, and essentially leaves the dipeptide. It's in solution. That's all we need to know. So what'll happen then if we do a self-reaction of a carboxylic acid? Interestingly, this will happen under just really high temperatures. That's all it takes. So let's say we've got 2 of these. Well, again, it's going to be the same mechanism where we're going to take that oxygen, pop it up right in there, take this, we're going to give us our 3, we're going to bring it back down, we're going to kick off another alcohol. What is this going to result in? Take a moment, pause, and see if you can predict it. We are going to get an anhydride, just like this. And if you want me to show this kind of explicitly here, we have this, pop it up. So when we pop it up, we have just 1 bond. So it's going to slam down. So we have 2 bonds. This is going to kick off that alcohol. Oop, remove it. So then it's going to leave our carboxylic acid attached there. But just for the sake of cleaning this, I'll leave that as it is. So this is our anhydride synthesis. So really, I want you to notice that the pattern is the exact same for all of these reactions. And this is what the MCAT wants you to know. It doesn't want you to memorize a bunch of different reactions. It wants you to be able to think on your feet and say, okay, where is the partial positive charge? Where's my nucleophile? Nucleophile goes in, attacks, opens up that carboxylic acid, makes that oxygen negative. Negative electrons come down, close it, and you kick off what was there before, leaving you with whatever you added, whether that's an amide, an acyl halide, or even we had 2 carboxylic acids reacting under really high temperature. In the next video, we're going to cover some slightly trickier reactions that you'll still want to know for the MCAT, but I want to thank you for watching our video on these common carboxylic acid reactions, and I will see you next time.